Hello everyone, welcome to the method video for Physics 1.1 for practical investigation. This investigation is looking at the idea of spring compression. So here we've got our spring attached to a small wooden block. It's got a nail through it and a washer on the top so we can add masses to the top of it. And we're looking at the relationship between the mass that you add to the spring and how compressed the spring is going to get. We're using the context of base isolators in buildings that help to stabilize buildings during earthquakes. So they're really common in places like Wellington. And those of you who have been to Te Papa may have seen them. There's a base isolator on display outside the main doors of Te Papa. Really important piece of structural equipment for the building. So what we're going to do is we're going to use our ruler, we're going to use our stand with our spring, and we're going to use our masses, and we're going to do some measuring, and then you're going to be able to do some work with your data. So a couple of things to do to start with. You need to measure the original length of your spring. So you need to get nice and close down, get nice and close to eye level, and measure from the top of the piece of wood, top of the base, to the washer. That is the length of your spring. That is the original length of your spring, and it should be somewhere about 5 centimeters, but your springs will vary in length, so make sure that you record them accurately. And that can be written down in your data sheet in a box that says original spring length, so you record that length in there. Then you're going to add your first mass, and then same measurement again from the top of the base piece of wood to the very bottom of the mass, because that's sitting on top of the washer, so we can assume that they're at the same level. And then we'll record our piece of data in our table. And then we add our second mass. We're now up to 200 grams, or 0.2 kilograms. So these are 100 gram masses. You've been using 50 gram masses previously for the bungee practice, so make sure that you do realize that these are different masses, so when you're recording them in your table, make sure you use the correct mass. Alright, so again we measure from the top of the wood to the bottom of the mass, and we record that piece of data in our table. And then we move on to the third mass. You can see where this is going. We record from the top of the piece of wood to the bottom of the lowest mass on the stack there, and we record that. And then we add our fourth mass. We're now up to 400 grams, or 0.4 kg. And we record that. And then our final mass, we're up to 500 grams. We're going to record that. Okay. We then remove all of the masses. Have a quick check to make sure that the spring hasn't been compressed out of shape. It shouldn't be. They're pretty stiff springs. So that's looking good. That's still the same measurement I had before. That's fine. And now we're going to repeat what we just did. So again, up to the bottom of the mass, from the top of the piece of wood. And we record that. Then for the second one, same again. Measure up to the bottom of the first mass, and we record that piece of data. So you're going to do repeats for all of the masses. You need to do a minimum of 4 different masses, and you need to do you do need to do repeats in order to get an average. So for those of you who are looking at getting merit or excellence, you're going to have to do averages. So that means you're going to have multiple repeats, which means a minimum of 3 repeats for each mass that you're doing. And then you find your average, and then that is the data that's going to go into your graph. Now there are a couple of little things you might encounter that can be slightly tricky. One of them is that the masses don't necessarily sit perfectly straight on here. They might tilt on a little angle. You can adjust those. You can actually just sort of hold them in place a little bit. Just make sure you're not pressing down on the spring when you do that. Just make sure that you're actually just nudging it so that it's straight, so that it gives you a measurement that you can work with. You can include the wooden base in your measurement, but I advise against it, because this is a constant. It's not changing length. So that's not actually anything to do with the spring compression, which is what you're measuring. So that is important to remember that. If you do just include this in your measurements and you were to measure the entire thing from the bottom of the base to the top of the washer, then you would at some stage need to then remove this from your equation. So that's something that you shouldn't really be looking to do, just as a a reminder to you there. Okay, this is a reasonably straightforward experiment. It's a lot easier to set up and get through than the bungee practice that you've done. So those of you that have gone through that, completed it, and done reasonably well in it, and gotten some feedback from your teachers, this should seem quite a bit simpler. The setup's a lot simpler. There are photos in your assessment document showing you the setup. It's very straightforward. Just make sure that you're getting nice and close down to eye level to make those measurements, so that you're not looking at them from an angle, because that's going to affect one of your potential errors or sources of error for the experiment. So just ensure that you're getting nice and close down. Make sure that nothing's bouncing around when you're taking measurements. Everything's nice and as level as you can get it. Everything's nice and stable. And be very clear when you're recording your data that somewhere along the line you include your units of measurement, because otherwise we're not going to be able to give you the marks that you probably will end up deserving. Okay, thank you.